Okay, hi guys. Yeah, welcome back to this brand new session of operating system programming concepts. And the topic for today is this one, the Exec system call. I have already explained you like in detail, right, in my previous operating system concepts, in which I described about Exec system call, and the main function of the Exec system call is just to replace the current process with a brand new process. Okay, the basic concept is just that. And right now, going through all this situation, okay, I will just try to explain you by the means of solving the programming exercise. Okay, here are some list of exercises I will try to solve by using this kind of exact system call. So okay, if you guys can also check out the situation by okay, let's go here, let's go to the manual of Exec. If you go and check out the manual of the Exec, it says that execute a file, right? So what is going to do is execute a file inside the child, like most importantly, a child is trying to go to a brand new process. Like you create a new process, and one of the child process, okay, the child process that you fork and create a new child process will like execute this kind of system called exec to go to another new process. Okay, by and this process is something like a command or something like this. So yeah, you can go and check the description here. It says that the family of functions replaces the current process image with a brand new process image, so new process image. And similarly, here are some kind of more information provided. And the most important thing you guys have to understand is that this exec function, the return value is only returned only if an error occurs. Okay, so if no error occurs, then in such kind of situation, exec is going to just execute the system. Okay, execute the file. Okay, so just going to execute the file, is not going to return any kind of situation. So and in case of error, then it's going to return -1. So this is the thing you guys have to understand. Okay, let's switch back to the question, and here are some kind of list of examples of how to use it for each kind of family functions of exec. And for exec L, you use such kind of information. And also the second key important point you have to understand is all the parameters that are passed in a length must be terminated by 0. Okay, it's also said here, go and check. Maybe what is the thing? Isn't default. There must be something like it has said it. But overall it is terminated by null. The parameters that are passed are terminated by null. Okay, look, the list of arguments must be terminated by a null pointer, and since these are very deep functions, this pointer must be a cast character pointing to a null, or you can specifically write null. Okay, so this is the important key concept that you guys have to just be careful before starting this to solve this kind of programming problems. So overall, there are some family of exec functions, and you can use any of them. Okay, so most preferably I will use this exec LP because the important thing that you guys have to understand that the first parameter is always the if you go and check out here, the first parameter is always the path or a file. So it is said here. Okay, here is written the first argument by convention should point to a file name associated with the file being executed. Okay, so also this you have to understand this. So first parameter is just the is by convention the file name, and here you have the absolute path, whereas for here I am trying just the relative path, not even the relative, just the name. So this exec LP will directly go and search for this corresponding file name automatically. So this is the advantage, okay, for using exec LP. Okay, with this basic concept, let's begin our lab then. Okay, for the learning goals for this lab is just to use wait PID and exec system calls, and just try to learn how to use it and try to understand how to wait for the specific child and how to execute command in your own programs, right? Okay, now let's begin with exercise number 1. In exercise number 1, what you have to do is, using system call for wait PID, write a program that receives the number n from the command line do the following. So what I'll do, okay, I'm here in a code block, so I will try to write this corresponding program. Alright, so let's begin. First you include the standard header files, right? Then again you include the libraries, standard libraries, right? Then you include the Unix header file, Unix standard header file. Okay, so this is the core thing that you have to be careful about, Unix header file, because we are using this library, okay, to call all the system calls. Then lastly also we use the wait system call, right? Okay, we are passing the parameters, so be careful that you have to pass the arguments. C, right? And as I have done here is a double pointer. You guys can also do something like a pointer to an array is also a double pointer. Alright, so here let's begin. The situation is like I have to create n processes, and n is passed as a command from the command line parameter. So let's take n first. N equals to toy. I have already used this function just to convert the parameter passed to integer number, right? So after this, create n processor. For creating processes, we have to always be careful that we have to create this PID. We have to declare this PID identifier. Now, as we are creating n processes, what we have to do is we have to loop it. For that, we have to include we have to also declare the integer, and I equals to 0, I is less than something like n, or I plus plus. Alright, so but as I am starting to display it from the 1, so let me start from 1, let me equals to n. For creating the parent process, so we have to always remember that we have to call the system call for. Then let's check out if PID equals to 0, that means it's a child, and else if it's a parent. So child parent situation, okay, child and parent situation. So for the child, what you do is also let's check out it. The first child sleeps n seconds, and the second child sleeps for n minus 1 seconds, and so on. So the child is sleeping here, okay, for the convenience, and also we are using the wait PID to wait for this child to execute, because we have n number of processes. So okay, first let's first do is let's printf for convenience. Okay, standard out, and something like write something like okay, the child, this particular child is like we have n number of child or n number of processes that is created, and for each process we have like its own PID. So let's try to see the situation for each child. Let's print out the PID then, right? Get PID. Okay, sorry. Alright, then let's also print out that this is going to sleep for some kind of seconds. So standard out, okay. So this child is going to sleep for some particular seconds. Is sleeping for these seconds, right? So what you guys have to do is this child but for the second case is a different. Okay, so how can we manage this second case? For that I have a specific idea, that is just declare an integer z, and what we can do is we can define a new condition for j is greater than or equals to 1, because actually what is doing is the first child sleeps for n seconds, okay, and the second child sleeps for n minus 1 second. So you know the idea is if I put here also I, it's going to sleep for I, that means first child sleeps for first 1 second. So you know the particular point you have to understand is like we initialize the first this variable j to n, so that the condition provided is greater than or equals to 1, and it is going to decrement, so j minus minus. Alright, so after you declare this kind of condition, you can just directly write here j, that means it's going to sleep for this kind of seconds, then you sleep for this number of seconds. Then what you do is you exit and return the parameter, and what the parent here is going to do is you have to wait. Look, the parent waits for all the children, that is it waits sequentially starting with the first created to the last. We have to use the wait PID system call. Okay, let's use the wait PID. Wait PI, yes, it's here. The first parameter is the PID. So for each fork, this PID, the fork returns the PID, right, of a child, and though this PID is passed here, it waits for this particular PID, and it waits for the status, for this PID to change the status, and the option, for the option parameter, let's point at 0. Okay, let me show you one important thing. I have already shown you the manual of wait PID before, but for your clearance, look, it's waiting for a PID until it changes the status, and there are the options, and the options, okay, look, the value of options is an OR of 0 or more of the following constants. So it's better if you write just 0. These are some options which are used for like run immediately, full child executed, and there are some kind of situations here. Alright, and you will go through this situation. Also you have to be careful that the if PID can be anything like less than -1 or 0 or greater than 0, and they have some specific meaning with each situation of PID. Alright, so let's close these situations, and now what you have to do is always be careful about some. Okay, we are sleeping, we are waiting for the PID. Now what you have to be careful about, like we have to exit, and you exit it completely, and then you return 0. Right, so let's hope that this is working fine. Let's try to run it. It's not working. Status us only, yeah, I forgot to declare the status variable. Okay, what I see is I see that the child 1, the PID is printed out and the child 1 is sleeping for 5 seconds, right? Sleep for 5 seconds. The child 2 PID is printed out, sleep for 4 seconds. Child 3 PID is printed out, sleep for 3 seconds, 2 seconds, 1 second, and alright, the process return is 0. So this is the program that the question was asking for, and I am successful to deliver you the right program. Right? I guess you guys have understood this situation. Okay. And now let's go to exercise number 2. And what it says is modify exercise number 1 with wait instead of wait PID. How many times the parent has to call wait? I think it's the same thing. Right? If you just change out wait, you just close the previous program, compile and run it. Okay, we have to remove these parameters because wait is just going to take the parameter status, and it's the same thing. It's the same case. Okay, it's going to sleep for 5 seconds first for child 1, for 4 seconds for child 2, 3 seconds for child 3, and similarly. Alright, so here it goes. Now for exercise 3, so run in background mode the program you wrote in exercise 1 and 2 and use ps command, try to figure out how many zombie processes you have. So okay, so for this case we have to use the, okay, let's close this. We have to compile it in a GCC. So let's first it's exercise number 1, no, exercise number lab 5, exercise number 1, right? X1.c. Okay, so just copy and paste it here, save it here, close this, and then try to compile it, check it out. Yeah, exercise lab 5, exercise number 1. Okay, so for this now what you do is like compile it by GCC. Exercise number 1. Let's okay, here is some kind of concepts, and it is said that warning, value computed is not used on its value. Okay, so let's go and change this situation. It says that value complete is not used, and so what we can do, okay, we have to, we can also do that, something like this. Okay, yeah, right now it's working well. Now let's check for the executable file. Yeah, it's just there. And what the question says, okay, let's compile and check it first. Segmentation fault, because I have to also pass the argument, that is, let's pass it this time 3. Yes, see, so 3 seconds, 2 seconds, 1 second, and exit. Okay, so yeah, it's working fine. Now okay, so run in background mode the program you wrote in exercise 1 and 2 and use ps command, try to figure out how many zombie process you have. Okay, so this time let's pass 5 as argument. Let's run in a background mode by passing a person. Right, I have already taught you this about this background process and foreground process. Okay, this yeah, you know, while you are using in a foreground process you can type any command and you know, anytime. So the command result will be actually, look, you can see that there are two processes, exec 1 and exec 1 again. Again, if you type here, there is no more process because it has already executed. Alright, so this is to show here what happens inside. Okay, so there were two zombie processes, and at the end all the processes were executed because there is a wait process to synchronize the wait system called to synchronize this child process and the parent process, right? Which is going to wait for child process to execute. Now exercise number 4, you have to have download this exe4_4txt file and write a C program which will execute the following series of Linux commands. So this is the important concept, that we will use this exec LP, the family function of exec family, to try to solve this programming numerical, and we will try to clear the process. And the idea is command 2 and 3 has to be executed concurrently. That means they have to execute in a parallel manner, and it's like something one is going to execute this particular command, and whereas process number 2 and 3 will concurrently execute sort and wc command, whereas lastly this fourth process will execute this cat command. And here is given at the end of the execution, all of the children and the parent has to print a message, and consider the 4 commands, so 4 different processes which are executed by the parent. So okay, let's try to solve this problem. Okay, how can we execute this kind of Linux commands? By creating processes is by creating using a system called that is Exec. Okay, now let's go back to the code blocks to write this particular program. Okay, we need this again. Let's close this, that we don't need. We are not passing any arguments as a parameter. Let's close, remove this. Okay, so for this concept, you guys have to create 4 processes, right? Just check out 1, 2, 3, 4. So how shall it be done? Is okay, if not 4. So this is for child 1, process 1. You can write here also process 1, process 1. And what it does is, this is a child, right? So this, what it's going to do is like just standard output. Alright, so you just standard output is something, and this is like child. This is child actually, and the PID of this child will be displayed. Okay. Then what it does is going to execute this particular command. It will execute this copy command. Okay, and the path is the path you downloaded for exec file is to be different. Okay, so we have to use the exec system call, and we can use any. Let's use exec LP. Okay. The file path is specified by this, given by this name, that is copy command, to inject from this copy, and the command that I am using is copy, and the argument that I am passing more are the path copy, I mean the source file name and the destination file name. So source file name is something like, if you go and check out here, I have this file that is ex4_4.txt. okay, in my this current working directory, that is lab file. So ex4_4.txt. so you guys have to just be careful about writing ex4_4.txt, this file, right? this file should be copied to something like a new file. So you can write again something like new.txt file. Okay, it will be copied and the arguments are terminated by a null. Null must be passed like this. Alright, and if there is no error in this calling the system call, then this will be executed. Okay, the new process will be created, and the process is this command, the copy. Otherwise I have to print out that it's an error. Exec call, and lastly the parent. Otherwise, if not, okay, so if not fork, that means it's a child. If fork, it's a parent, so parent has to wait for the status. So we have to first parent status as declare the variable status. Similarly, I have to create so many other processes. So similar processes, okay, I can create like cases for let's copy this. I have to create another process, that is process 2. Similar thing, the child also will be printed out, and this time we are going to use this command, that is sort. Okay, this file name is given by this name. You can pass also the name of the file and name of the command, so that the command will automatically go and find the file path. And the command I'm using sort, so there are some parameters we have to pass that are -k. As you guys already know that for sort, if you go and check out the manual of sort, you can say that -k is for to define the field, okay, which field you are choosing, either it's the first or second row of the file that you want to sort. And your sort also, the field is defined as 2, and either you are sorting numerical, so it is defined by option n, and the name of the file is something like that you are sorting is exo_4.txt, right? And whereas also you can check out the option, this is O, so this is just to show you that the output, okay, is to be printed not in standard output but in this file, that is this exo_4.sorted. So let's print this. .txt, lastly terminated by null. So yeah, we are done with this, and otherwise we just right, if this exec system call works, it just goes to the new process and execute this command, and creates a new process. Otherwise the exec call is just printed out. So similarly, and here what is said is that this two must execute concurrently, so they must execute together. So wait is not performed here. Again, copy this, yeah, because we want to create process 3, this process, and the command that we are executing is wc. So yeah, the file name is given by this name wc, whereas the command is wc, it's word count, whereas the text that you are doing is exo_4.txt. So this was remove this extra that are not needed. Alright, so yes, we are okay with this. And similarly here they are working concurrent, so the parent waits the status together. Okay, lastly also we just copy this, create the last process, that is process number 4. Okay, and the command that we have to use is cat. So let's choose command cat, and command is cat, right? The name is cat, command is cat. And actually this is not my exe4, it's exe4 underscore txt. Okay, that is your exe4. Okay, now let's check out the situation, and lastly you exit, and lastly you return 0. Yeah, I guess we are okay, we are done with this situation. Now what we have to do is, let's just check out what it says. Is cannot state, no such file directory, sort cannot read. Okay, so yeah, just the initial check is okay, the work is done. Right now what we have to do is we have to go to the terminal and then try to compile and run it, okay, passing all the parameters. So let me create gedit this x5 exercise number 4, right, dot c. Yes, so what I have to do is just copy this. Where is the this is the thing, paste this, save this, close this, then what is it should be done, let's check it. Exercise number 4, yeah, it's just there, just here. Okay, now let's compile it. 1 x5 underscore, actually I should have written there ex lab 5x, but no problem, let's try to solve it by using this one. O.c minus o my ex4. Okay, yes, it's working well. Now let's check for the executable. Yeah, we have the executable. Now just try to execute it. ex4. Okay, so everything is done here. Okay, look, all this situation was performed, all these processes executed. Okay, and if you go and check out, lastly also it print out the word count for this text, right, and it also copied it. After copying it also just sorted. It's secondly after sorting it just print out the word count, the third process. Okay, and lastly fourth process just catenated the file. Okay, so for this okay, now let's check out situation. Before there was no this new file, text file, ex4 underscore 4 underscore txt. Right now here is, and also before there was no new text, also here the new text is generated. So let's check this, cat new.txt. Yeah, it's just same. Look, cat new.txt is same, the same file that was in this exe4 underscore 4 txt. Okay, now I will show you exe4 txt. Yeah, also look, cat exe4 underscore 4 txt is the same file, lab110, okay, 32421. Okay, here cat new.txt is 32421. Yeah, same. And also for let's check for the exe4 underscore sorted, is it sorted or not. So cat ex4 underscore 4 dot no 4 underscore sorted dot txt is, yeah, it must be sorted. So I for sorting I use the command like something like for example sort minus k, the field is second field, the numerically with this text and just output the sorted file to this, right? It was done here. For your clearance, I will just go to the manual of sort. Okay, if you go and check the manual of sort, what you have to use is sort, the option and the file. So what we use the option was, firstly we used was k. Yeah, if you go and k, sort through a key define gives location and type. Okay, and location, what was the location? That is the second row, so it goes from row wise. Okay, length, so it was defined 2, so it going to the second row of the line. So that means if you go and check out the file is something in this format. So this is the first row, that is first word. So k, it says that it goes to the second row, that is this one. Okay, now second column, that not row but actually second column, that is this one, right? And it is going to sort numerically. Wait, and sort, if you go to k, it says that the sort through a key define gives the location in a type. So location, if you specify any 2, means it is going to a second column. If you specify 3, that means it's going to a third column, and similarly. Whereas there was another key that was minus n, right? So it is n. Okay, let's check out the situation of n. Yeah, it's here. It's written as numeric sort. Compare according to a string numerical value. So it is sorting according to numerical. And lastly, there was also output O. There is O. Yeah, output. Write a result to a file instead of a standard output. So it will write the result to a file. Alright, so I think, okay, if you go and check out the cat.exe for the sorted text, it's sorted with the key defined, length, okay, and this was 2, and this was it sorted numerically. Then after sorting numerically, it just outputted the sorted text to this new text file, that is exe for the sorted.txt. Okay, I think this is all for this exercise. And lastly, we have the last exercise, that is exercise number 5. Just try to figure out what is the output of the following program. Okay guys, what is the output? What can be the output of this program? Okay, then compile it and run. So what's going on? Okay, it's like just try to execute this system called Exec. So and RB0 is passed. So let's see and the situation by ourselves, like what is going to be done. You can directly copy this, go here to your